There is a continent at the bottom of the world that for millions of years followed its own evolutionary path. A great ship of life cast adrift from the rest of the world. This is Australia, a land of ancient rocks and rust-red deserts, of sprawling eucalyptus forests and vibrant coral reefs, a vast biological laboratory where the story of life took a turn found nowhere else on Earth. Its journey as a solitary continent, an immense arc sailing through the currents of deep time, has resulted in a collection of animals so strange, so unique, that they seem to have sprung from a different creation. As we embark on this journey into the heart of Australia's wild history, it's always fascinating to know where our stories are heard. Take a moment to comment where you are listening from and what time it is. And if you enjoy explorations like this, please subscribe so you're notified of future stories. The story of Australia's fauna is a narrative written over hundreds of millions of years, a tale of cataclysmic separations, climatic extremes, and magnificent adaptation. It begins long ago, when this landmass was wedged into the heart of a colossal supercontinent, and it continues today, in a world grappling with the consequences of a human presence that is, in geological terms, a mere blink of an eye. For nearly 45 million years after its final break from Antarctica, the continent drifted north across the surface of the planet, its inhabitants evolving in almost complete isolation. This long solitude allowed ancient lineages to survive and radiate into a dazzling array of forms, a world where mammals carry their young in pouches, lay eggs like reptiles, and where birds can stand taller than a man. The great evolutionary dynasties of placental mammals that rose to dominate Asia, Africa, and the Americas had no foothold here. Instead, the marsupials, those pouched mammals, seized the stage, diversifying to fill every available niche, producing creatures that paralleled the wolves, cats, monkeys, and badgers of other lands. Here, evolution ran its own grand experiment, resulting in a kangaroo that can bound across the plains at speeds of 70 kilometers per hour, nearly 45 miles per hour, and a sleepy koala that subsists on a diet of toxic leaves. But the marsupials are only part of the story. This is a land of reptiles of an ancient caste, of snakes whose venom is the most potent on the planet, and crocodiles that have remained apex predators, virtually unchanged for millions of years. It is a continent whose symphony is sung by birds of incredible diversity and intelligence, from the raucous laughter of the kookaburra to the intricate constructions of the bowerbird. To truly understand the story of these remarkable survivors, we must first travel back much further, to a time when Australia was not an island at all, but a green corner of the great southern supercontinent of Gondwana. Our journey back in time takes us to a world that would be utterly unrecognizable to modern eyes, to the Mesozoic era, a time when the Earth's continents were locked together in different configurations. The great southern supercontinent of Gondwana was an immense landmass, a colossal jigsaw puzzle of what would become South America, Africa, Antarctica, the Arabian Peninsula, the Indian subcontinent, and of course, Australia. For over 300 million years, this vast continent was a stage for the grand drama of evolution. Australia itself was nestled beside Antarctica, far closer to the South Pole than it is today. Yet the climate was radically different. This was not a world of ice caps and frozen polar wastes. The globe was a much warmer place, a greenhouse world where vast, temperate rainforests flourished under skies filtered by the light of a younger sun. These forests were not dominated by the eucalypts and acacias that define Australia today. Instead, they were composed of ancient lineages of conifers like podocarps and the magnificent southern beeches of the genus Nothophagus, trees whose descendants still cling to life in the cool, damp corners of Tasmania and the high mountain ranges of the mainland, living echoes of a greener, wetter past. Ferns grew in profusion, creating a lush understory that carpeted the forest floor. Through these primeval forests stalked a menagerie of dinosaurs unique to the southern hemisphere. Great long-necked sauropods browsed the high canopy, while herds of ornithopods, like the distinctively nosed Muttaburrasaurus, a creature that grew up to 9 meters, or nearly 30 feet in length, moved through the vegetation. Predators, like the Australovenator, a swift and slender hunter, about 6 meters long, or around 20 feet, stalked these herbivores through the perpetual twilight of the forest floor. The fossil record of this period in Australia is fragmentary, tantalizingly incomplete. But every bone fragment and footprint discovered adds a new brushstroke to the picture of this vast world. But beneath the feet of these reptilian giants, a new kind of animal was quietly making its way. Mammals had appeared on the world stage, and in the Gondwanan forests, they were represented by the 3 great branches of mammalian life. There were the placentals, the group that would go on to dominate most of the world. But here in the south, they were just one contender among several. Competing with them were 2 other ancient lineages, the strange, egg-laying monotremes, and the marsupials, the pouched mammals. For tens of millions of years, these groups coexisted. Small, often nocturnal creatures scuttling through the leaf litter, hiding from the reptilian giants that ruled the day. The marsupial strategy of giving birth to a tiny, underdeveloped neonate, which then completes its development in a protective pouch, was not some primitive or inferior system. It was simply a different and highly successful solution to the challenge of reproduction, one that would prove to be spectacularly triumphant in the Australia to come. Other key players in modern Australia's fauna also trace their ancestry directly back to this Gondwanan cradle. The ancestors of the great flightless birds, the ratites, which include the modern emu and cassowary, as well as the ostrich of Africa and the rhea of South America, all strode through these ancient forests, their shared heritage a testament to the time when their homelands were all connected. In the freshwater rivers and lakes of Gondwana swam creatures like the lungfish, a living fossil whose lineage stretches back almost 400 million years, an animal that can breathe air and survive droughts by burying itself in the mud, a trick that would serve its descendants well in the drying continent of the future. The breakup of this immense landmass was not a single, violent event, but a slow, inexorable tearing apart that stretched over 100 million years. The first great rifts appeared around 180 million years ago, as Africa and South America began to peel away from the rest of the supercontinent, opening up the nascent Atlantic Ocean. Later, the landmass that would become India broke off and began its long, lonely journey north, eventually colliding with Asia to thrust up the Himalayas. Around 85 million years ago, a rift began to open between Australia, Antarctica, and the land that is now New Zealand. New Zealand was the first to be cast adrift, its own unique fauna, including the giant moa birds, beginning a long history of isolated evolution. For millions of years more, however, Australia remained tethered to Antarctica. A forested peninsula connected southeastern Australia to the Antarctic coast, allowing the exchange of flora and fauna between the two. The climate was still cool and wet, and the southern polar forests, filled with nothofagus and podocarps, covered both land masses. But the tectonic forces were relentless. The rift separating the two continents continued to widen. Finally, around 45 million years ago, the last land bridge was severed. A deep ocean channel, the Tasmanian Gateway, opened between them. This was the moment that the Great Australian Arc was truly launched. As Australia began its slow northward drift at a rate of a few centimeters, just an inch or so per year, a profound and world-altering climatic event was set in motion by this final separation. With an unbroken expanse of ocean now encircling Antarctica, a powerful new ocean current, the Antarctic Circumpolar Current, was born. This colossal, clockwise flowing current acted as a thermal barrier, isolating Antarctica from the warmer waters of the mid-latitudes. The consequences were catastrophic for the southern continent. Antarctica began to freeze, its temperate rainforests dying off to be replaced by the vast ice sheets that persist to this day. This global cooling event, coupled with Australia's steady drift north into warmer and drier latitudes, began to utterly transform the continent's environment. The cool, wet Gondwanan climate that had persisted for so long started to disappear. The ancient rainforests began to retreat, contracting into the wetter coastal and mountainous regions where their remnants still survive. In their place, new, hardier types of vegetation began to spread across the landscape. Plants adapted to sunlight, fire, and a lack of reliable water. This was the birth of the sclerophyll forests, dominated by the tough-leaved eucalypts and wattles that are now the quintessential Australian flora. This radical environmental shift placed immense selective pressure on the continent's animals. The fauna of the Ark, the survivors of the Gondwanan breakup, were now faced with a new challenge: adapt to a progressively drier and more seasonal world, or perish. The old rainforest specialists struggled, but for other groups, this new environment was a land of opportunity. For the marsupials in particular, this was their moment. With the placental mammals having had only a minor presence before the continent's isolation, the marsupials faced few competitors. They began to radiate outwards, diversifying at an explosive rate to fill the astonishing variety of ecological niches that were opening up in this changing landscape. They became grazers and browsers, carnivores and insectivores, climbers and diggers. They evolved into forms that uncannily paralleled the placental mammals of other continents, a spectacular example of convergent evolution. There were marsupial mice, marsupial cats, marsupial wolves, and even marsupial moles. The story of Australian fauna from this point forward is the story of this incredible radiation, a tale of evolution working in splendid isolation on a continental scale. And as the millions of years passed and the continent continued its northward journey, the changing climate and environment would give rise to a new and spectacular cast of characters. An age of giants that would be the crowning glory of Australia's long solitude. This age of giants, the Pleistocene epoch, which began roughly 2.6 million years ago, was a time when the Australian continent was populated by beasts of a scale that strains the modern imagination. The familiar kangaroos and wombats of today had colossal cousins, and the top predators were not dingoes, but creatures of a far more formidable and alien design. The landscape itself was different, a shifting mosaic of woodlands, grasslands, and forests, shaped by the planet's cyclical ice ages, which, even in Australia, brought cooler, drier conditions and lowered sea levels, connecting the mainland to New Guinea and Tasmania. In this world roamed Diprotodon uptatum, the largest marsupial that has ever lived. Picture a creature the size of a hippopotamus or a white rhinoceros, weighing up to 2,800 kilograms, or over 6,000 pounds, and measuring nearly 4 meters in length, about 13 feet from nose to tail. Despite its immense size, its closest living relatives are the wombats and the koala, a fact betrayed by the structure of its feet and its 2 large, forward protruding incisors in its lower jaw, which give it its name, meaning 2 forward teeth. For tens of thousands of years, herds of these colossal herbivores moved ponderously through the open woodlands and plains. Their powerful, pillar-like legs supporting their massive frames. They were bulk feeders, using their sharp incisors to shear through tough vegetation, shrubs, and leaves. Their fossils are among the most common found in Australia, often discovered in great numbers around ancient waterholes and salt lakes, such as Lake Callabonna in South Australia, suggesting that during times of drought, vast herds would become trapped in the drying mud, leaving a poignant snapshot of their final moments. The existence of such enormous herbivores presupposes the presence of equally impressive carnivores to hunt them, and Pleistocene Australia did not disappoint. The apex predator of this lost world was a beast of astonishing power and specialized weaponry. Thylacoleo carnifex, the marsupial lion. This was no feline. It was a member of the same order as the possums and wombats, a lineage that had taken a sharp evolutionary turn towards hypercarnivory. Thylacoleo was built for power, not for speed. It was about the size of a modern jaguar, but far more robustly built, with immensely powerful forelimbs. It possessed a semi-opposable thumb on its hand, tipped with a huge, retractable claw like that of a cat, likely used for grappling with prey. But its most terrifying feature was its skull. Unlike placental carnivores, which kill with canine teeth, Thylacoleo had evolved its incisors into a pair of enormous shearing blades, like a set of bull bolt cutters. Coupled with some of the most powerful jaws, pound for pound, of any mammal predator, this animal could deliver a catastrophic bite, shearing through flesh and bone with devastating efficiency. Its molars were reduced to blade-like carnassials, perfect for slicing meat from a carcass. This was an ambush predator, a creature of terrifying strength that would drop from a tree or burst from cover, dispatching its victims not with a suffocating bite to the throat, but with a single skull-crushing or spine-severing application of its uniquely adapted teeth. Yet, even the mighty Thylacoleo would have been wary of another predator that shared its domain, a hunter that came not from a mammalian, but from a reptilian dynasty. This was Megalania, or Varanus priscus, a gargantuan monitor lizard that dwarfed its living relative, the Komodo dragon. While precise measurements are debated due to the incompleteness of fossil skeletons, conservative estimates place Megalania at lengths of at least 5.5 meters, or 18 feet, with some suggesting it could have reached up to 7 meters, or 23 feet, and weighed well over 600 kilograms, more than 1,300 pounds. It was the largest terrestrial lizard ever to have lived, with its serrated, blade-like teeth and a powerful septic bite, possibly enhanced by a true venom gland system similar to modern goannas. Megalania was an apex predator of the highest order, capable of bringing down even adult Diprotodon. Its heavy, armored scales would have protected it from attack, and its sheer size and power would have made it a truly terrifying presence in the Pleistocene landscape. This was a monster from an earlier age of reptiles, surviving and thriving in a world of giant mammals. The cast of this megafaunal drama was extensive and diverse. Grazing alongside the Diprotodon were giant kangaroos, some of which were utterly unlike their modern relatives. The genus Procoptodon, the giant short-faced kangaroos, could stand up to 2 meters tall, or 6.5 feet, and weighed over 230 kilograms, or 500 pounds. They had a single large toe on each foot, rather than the multiple toes of modern kangaroos, and a short, robust skull reminiscent of a primate's, which would have allowed for a very powerful bite to process tough plant matter. Instead of hopping, their rigid spines and specialized hip structure suggest they may have walked bipedally, like a person, reaching up with their long arms to pull high branches down to their mouths. Striding across the plains were also the great flightless birds, the mihirungs, or thunderbirds. The last of this lineage was Genyornis newtoni, a bird standing over 2 meters tall, or nearly 7 feet, and weighing as much as an emu, but with a far more robust build. Its massive beak has been the subject of much debate. For years, it was thought to be a formidable carnivore, but more recent evidence from its fossilized gizzards and the chemistry of its eggshells suggests it was a herbivore, possibly feeding on fruit and other soft vegetation. The waterways, too, were home to giants, like the colossal constrictor snake, Wanambi, which grew to over 5 meters, or 16 feet in length, and hunted kangaroos and other large prey from ambush at the water's edge. This rich and formidable world of giants, a unique evolutionary pinnacle of Australia's long isolation, existed for over 2 million years. But then, in a geological instant, it vanished. The fossil record shows a catastrophic decline, with the majority of these magnificent beasts, every terrestrial vertebrate species weighing over 100 kilograms, or 220 pounds, disappearing from the continent. The Great Extinction Event, which peaked around 46,000 years ago, has been the subject of one of science's most enduring and heated debates. What could have possibly brought this long-reigning dynasty of giants to such an abrupt and total end? 2 main culprits have been proposed: the dramatic swings in the Earth's climate, and the arrival of a new, uniquely intelligent and adaptable predator. The climate change hypothesis points to the increasing aridity of the Australian continent. The Pleistocene was punctuated by a series of ice ages that locked up vast amounts of the world's water in polar ice caps, leading to prolonged periods of severe drought in Australia. The proponents of this theory argue that this climatic instability, particularly the intensification of dry periods, led to a transformation of the landscape. Water sources disappeared, and the mixed woodlands that supported a wide variety of browsers and grazers gave way to tougher, less nutritious, fire-adapted vegetation and open desert. For the megafauna, with their huge bodies requiring vast amounts of food and water daily, such a resource crash would have been devastating, leading to widespread starvation and population collapse. The second suspect, however, adds a far more dramatic element to the story: humanity. The first indigenous Australians arrived on the continent at least 65,000 years ago, meaning they coexisted with the megafauna for nearly 20,000 years. The overkill hypothesis suggests that these skilled and cooperative hunters, armed with sophisticated tools and strategies, were simply too much for the native animals to handle. The megafauna, having evolved in the absence of such a predator, may have been slow, unwary, and easy targets. But a more subtle and perhaps more powerful version of the human impact theory centers not on the spear, but on the flame. The arrival of humans corresponds with a dramatic increase in charcoal deposits in sediment layers, suggesting a change in the continent's fear regime. The first peoples were expert practitioners of what is now called fire stick farming, the systematic and purposeful burning of the landscape to promote the growth of specific useful plants, to clear pathways for travel, and to flush out game. This regular, low-intensity burning would have profoundly altered the ecosystem, favoring fire-tolerant sclerophyll plants, like eucalyptus, over the softer vegetation the megafauna relied upon, effectively engineering the environment in a way that drove the giant herbivores to extinction, and their predators along with them. The truth is likely a combination of these two powerful forces. The megafauna were probably already under immense stress from a continent that was growing progressively drier and more difficult to survive in. Their populations may have been fragmented and declining. Into this precarious situation stepped humanity. The combined pressure of a shifting climate and the arrival of a supremely adaptable predator, one that not only hunted, but actively reshaped the entire landscape to suit its needs, was the final, fatal blow. The great beasts vanished, leaving behind only their sun-bleached bones and the faint echoes of their presence in the dreamtime stories of their human successors. Their disappearance left a profound void in the ecosystem, forever changing the evolutionary path of the continent's surviving fauna and leaving a land that, while still unique, was a mere shadow of the giant haunted world it had once been. With the thunderous footsteps of the giants silenced forever, the Australian continent fell under a new and quieter dominion. The world they had left behind was one of harsher climates and more open spaces, a land that now belonged not to the colossal, but to the adaptable. In this changed world, the marsupials, those pouched mammals that had lived for millions of years in the shadow of the megafauna, rose to prominence, their ultimate triumph rooted in a reproductive strategy of profound subtlety and brilliant efficiency. This strategy, perfected over eons of evolution in a land of unpredictable boom and bust, was their secret weapon. Unlike placental mammals, which invest enormous energy in a long and complex pregnancy, marsupials hedge their bets. They give birth to a startlingly underdeveloped infant, a mere embryo, after a gestation period that can be as short as 12 days. This tiny, translucent creature, often no larger than a jelly bean, and weighing less than a single gram or a fraction of an ounce, must then embark on the most perilous journey of its life. The birth of a red kangaroo is a spectacle of instinctual determination. The mother, after a pregnancy of only 33 days, sits on the ground with her tail forward between her legs, creating a channel. From the birth canal emerges a tiny, pink, worm-like neonate. It is blind. Its hind legs are mere buds, but its forelimbs are surprisingly well developed, complete with sharp little claws. It has a powerful sense of smell and an innate, unwavering sense of direction. Upwards. Guided by instinct and gravity, it begins to climb, a heroic, solo ascent through the dense fur of its mother's abdomen, a journey of perhaps 15 centimeters, or about 6 inches, that can take several agonizingly slow minutes. Its mother does not help, beyond licking a path in her fur to reduce the friction. The tiny creature hauls itself along, hand over hand, in a swimming motion, a fragile spark of life navigating a mountain of hair. Its destination is the forward-facing opening of the pouch, a warm, protected haven. Once inside, it latches on to one of the 4 teats. The teat immediately swells in the joey's mouth, creating a firm attachment that prevents it from being accidentally dislodged. Here, in this second womb, its real development begins. The mother's body performs a biological miracle. The milk she produces is not a static substance. It is a dynamic, life-sustaining fluid that changes its composition precisely to meet the needs of the growing joey. In the early stages, the milk is dilute and rich in antibodies, providing passive immunity to the undeveloped infant. As the joey grows, the milk becomes progressively richer in fats and proteins, fueling its rapid development. But the kangaroo's reproductive genius goes even further, culminating in a strategy known as embryonic diapause. This allows a female red kangaroo to exist in 3 reproductive stages at once. She can have a mature joey that has left the pouch but still returns to suckle, known as a joey at foot. It drinks from a specific teat that produces high-fat milk. Inside her pouch, she can be nurturing a much younger joey, permanently attached to a different teat that provides the high-carbohydrate milk suitable for its earlier stage of development. And most remarkably, in her uterus, she can hold a tiny, dormant embryo, a blastocyst of about 100 cells, its development paused, waiting for the right signal. If the older joey in the pouch dies, or when it is old enough to leave permanently, the dormant embryo resumes its development, is born, and makes its own perilous climb to a now vacant teat. This incredible system allows the kangaroo to breed continuously and rapidly when conditions are good, with plentiful food and water. But to instantly halt the reproductive process during a drought, saving precious energy without losing the next generation. It is the perfect adaptation for the arid heart of Australia, a continent where the next rainfall is never guaranteed. This efficiency is mirrored in their movement. The kangaroo's hop, using its massive Achilles tendons like giant elastic springs, is one of the most energy-efficient forms of locomotion at high speed on Earth, allowing them to cover vast, parched distances between feeding grounds with minimal effort. While the kangaroos conquered the plains, another marsupial took to the trees, embarking on a path of extreme specialization. This was the koala, an animal that built its success on a diet that is utterly toxic and nutritionally poor for almost every other mammal: the leaves of the eucalyptus tree. Eucalypt leaves are packed with tough, fibrous lignin, low in protein, and most critically, are saturated with a cocktail of poisonous phenolic and terpene compounds. To survive on such a challenging food source, the koala evolved a suite of extraordinary adaptations. Its digestive system features an enormous cecum, a specialized fermentation chamber up to 2.5 meters long, or over 8 feet, packed with unique gut microbes that are able to break down the tough fibers and, crucially, help to detoxify the poisonous oils. Its liver is also highly specialized, exceptionally efficient at neutralizing the toxins that make it past the gut. But this diet comes at a cost. Extracting so little energy from its food forces the koala into a life of extreme energy conservation. They are famously lethargic, sleeping for up to 20 hours a day, their slow metabolism ticking over at a rate that conserves every precious calorie. They move with a deliberate slowness, their strong, sharp clawed paws and opposable digits on both hands and feet, giving them a vice-like grip on the branches. Even their social life is low-key, punctuated by the startlingly deep, bellowing calls made by the males during breeding season. The koala represents a different kind of marsupial triumph, not one of speed or reproductive opportunism, but of mastery over a chemical fortress, a quiet conquest of an ecological niche that no other mammal could occupy. From the treetops, our story moves to the world beneath the soil, to the domain of Australia's master burrower, the wombat. These powerful, barrel-chested herbivores are the bulldozers of the marsupial world, ecosystem engineers of the first order. With their short, powerful limbs and broad, shovel-like claws, they are capable of excavating vast and complex burrow systems, known as warrens, which can have multiple entrances and stretch for over 30 meters, or nearly 100 feet, through hard earth and under rocks. These burrows provide a crucial refuge from predators and, most importantly, from the extreme temperatures of the Australian summer and winter, maintaining a stable, humid microclimate deep underground. Their entire anatomy is a testament to this fossorial lifestyle. A wombat's pouch faces backwards, a simple but ingenious adaptation that prevents it from being filled with dirt as the mother digs. Their bodies are solid blocks of muscle and bone, and their most peculiar defense is their reinforced rump. When threatened, a wombat will dive headfirst into the nearest tunnel, blocking the entrance with its extremely tough, cartilage-plated backside. Any predator foolish enough to follow it into the burrow risks being crushed against the tunnel roof by a powerful backward kick. Even their droppings are unique. Wombats are the only known animal to produce cube-shaped scat, a trait that is thought to help mark their territory by preventing the pellets from rolling away from prominent locations like logs and rocks. They are relentless grazers. Their rodent-like, ever-growing incisors perfectly suited for clipping tough native grasses. The success of the wombat lies in its mastery of the earth, its ability to create its own stable world beneath a landscape of often hostile extremes. Another branch of the marsupial family tree that found its own unique path to survival and prosperity in the wake of the fallen giants. But for all their unique adaptations, the marsupials were not the first or the strangest mammals to claim Australia as their own. To find the continent's most ancient mammalian lineage, we must look past the pouch and delve into a deeper, more mysterious chapter of evolutionary history. A chapter that is still being written by two of the most extraordinary creatures on the planet. These are the monotremes, living fossils that represent the earliest, most divergent branch of the entire mammalian family tree. They are ghosts from a deeper time, survivors of a lineage that stretches back over 160 million years into the heart of the Jurassic period, a time when their ancestors scurried under the feet of dinosaurs. They are mammals, unequivocally so. They have fur, they are warm-blooded, and they produce milk to feed their young. But they retain a collection of traits from their distant reptilian forebears that sets them utterly apart from all other mammals on Earth, the most famous and defining of which is that they lay eggs. When the first specimen of a platypus, or Ornithorhynchus anatinus, arrived in Great Britain at the end of the 18th century, it was met with utter incredulity. The naturalists at the British Museum, who examined the dried skin in 1799, were convinced it was a hoax, a taxidermist's elaborate prank. They suspected that a duck's bill had been cunningly stitched onto the body of a creature resembling a beaver or an otter, and spent considerable time with scissors and scalpels trying to find the stitches. They found none, because this improbable beast was entirely real. The platypus is a creature of the freshwater rivers and streams of eastern Australia. A semi-aquatic specialist perfectly tailored to its environment. Its body is streamlined, covered in a coat of incredibly dense brown fur, up to 900 hairs per square millimeter, which traps a layer of air against the skin, providing superb insulation and waterproofing even in the coldest mountain streams. Its tail is broad and flat like a beaver's, used for steering in the water and for storing fat reserves. Its feet are webbed, but the webbing on the front feet, which provide the main propulsion for swimming, is retractable, pulling back to expose strong claws used for digging the extensive burrows in riverbanks where it rests and raises its young. Yet it is the bill that is the platypus's true marvel. Far from being the hard, keratinous bill of a bird, it is a soft, pliable, rubbery structure covered in leathery, dark skin. And this skin is one of the natural world's most sophisticated sensory organs. It is riddled with nearly 100,000 specialized receptors arranged in distinct stripes across its surface. 40,000 of these are electroreceptors, and 60,000 are mechanoreceptors. When a platypus dives, it does so with its eyes, ears, and nostrils all sealed shut. It swims through the murky darkness in a state of sensory deprivation, blind and deaf to the world around it. But it is anything but helpless. As it sweeps its head from side to side, it is reading the water in a way we can barely comprehend. The bill's mechanoreceptors detect the tiniest disturbances in the water, the faintest pressure waves created by the movement of a freshwater shrimp or a dragonfly nymph. Simultaneously, the electroreceptors detect the minute electrical fields generated by the muscle contractions of that same prey. The platypus, in effect, sees the world as a shimmering tapestry of invisible electric fields. The combination of these two inputs creates a precise three-dimensional map of its surroundings, allowing it to pinpoint and snatch its prey with astonishing accuracy, all without once using its sight or hearing. This strange creature's reproductive life is just as astonishing. After mating, the female digs a special, deep nesting burrow, which can be up to 20 meters or over 65 feet long, and plugs the entrance with soil to maintain a stable temperature and humidity and to deter predators. In a nest of damp leaves and reeds at the end of this tunnel, she lays 1 to 3, but usually 2, small, leathery-shelled eggs, each about the size of a grape. She then incubates them, not by sitting on them like a bird, but by curling her warm body around them for about 10 days. When the young, called puggles, hatch, they are tiny, blind, and hairless. And here, the platypus reveals another of its mammalian secrets. The mother has no nipples. Instead, milk is secreted from specialized pores in the skin of her abdomen, collecting in grooves where the puggles lap it up from her fur. It is a method of lactation so ancient it may well be how the very first mammals fed their young. Yet for all its seemingly gentle and bizarre attributes, the platypus holds one more surprise. The male is venomous. On the hind ankle of every male is a sharp, hollow spur, about 1.5 centimeters, or just over half an inch long, connected to a venom gland in the thigh. This venom is a complex cocktail of proteins, and while not lethal to humans, it is known to cause immediate, excruciating, and long-lasting pain that is resistant to morphine and can persist for weeks or even months. The venom apparatus is used primarily in combat between rival males for mating rights during the breeding season. A brutal reminder that even this most peculiar of creatures is subject to the fierce pressures of natural selection. The second living testament to this ancient lineage is the echidna, or spiny anteater, where the platypus adapted the monotreme blueprint for a life in the water. The echidna applied it to a life on land, becoming a powerful digger and a specialist feeder on ants and termites. The short-beaked echidna, Tachyglossus aculeatus, is found all across Australia, from alpine meadows to arid deserts, a testament to its remarkable adaptability. Its body is covered in a formidable coat of long, sharp spines, which are actually modified, thickened hairs, interspersed with coarse fur for insulation. Like its aquatic cousin, the echidna possesses a snout that is a highly sensitive sensory organ, equipped with both mechanoreceptors and a smaller number of electroreceptors, which it uses to detect the underground movements of insect colonies. It has no teeth. Instead, it uses its immense strength and the huge shovel-like claws on its feet to tear into solid termite mounds, rip apart rotting logs, or dig furiously into the earth. Once it has breached the insect's fortress, it deploys its other secret weapon, a slender, sticky tongue that can be up to 17 centimeters, or nearly 7 inches long. This tongue can flick in and out of its tiny mouth, opening at a rate of 100 times per minute, slurping up vast quantities of ants, termites, and larvae, which are then ground up against hard pads at the back of its throat. Its primary defense is to use those same powerful limbs to dig. When threatened, an echidna doesn't run. It digs straight down, disappearing into the soil with astonishing speed, leaving only its impregnable back and spiny rump exposed to a baffled predator. The echidna's reproductive cycle combines the strangeness of the platypus with the pouch-based strategy of the marsupials in a stunning display of convergent evolution. After mating, the female develops a temporary pouch, a simple fold of skin and muscle on her abdomen. Into this pouch, she lays a single soft-shelled egg, the size of a small marble. The egg is incubated here, and after about 10 days, the puggle hatches. It is a tiny, embryonic creature, which, like a marsupial joey, latches onto a specialized area within the pouch, the milk areolae, or milk patches, and begins to suckle the nutrient-rich milk that oozes from the skin. It remains in the pouch for about 55 days until it begins to develop its sharp spines, at which point its continued presence becomes rather uncomfortable for the mother. She then deposits the young echidna in a safe, hidden nursery burrow, returning every 5 to 10 days to provide a large feed of milk until it is old enough to fend for itself. The monotremes, in their egg-laying, milk-secreting, venom-spurring, and electricity-sensing glory, are not primitive failures or evolutionary misfits. They are a story of immense success and endurance, the last surviving whispers of the very dawn of mammals. A chapter of life's history that was closed and forgotten everywhere else on Earth, but which, on the isolated arc of Australia, is still being read aloud. While the monotremes offer a unique glimpse into the dawn of mammals, the skies and forests of Australia are dominated by a different class of vertebrate, one whose own story is just as deeply entwined with the continent's long solitude. This is the world of birds, a lineage that carries the direct genetic echo of the dinosaurs. And nowhere is that ancient reptilian heritage more apparent than in the giants that stride across the open plains and stalk the dense rainforests. The most iconic of these is the emu, Dromaeus novaehollandiae, a bird that has become a symbol of the continent itself. Standing up to 1.9 meters, or over 6 feet, in height, the emu is the second tallest bird in the world, a shaggy, brown-feathered titan built not for the sky, but for the endless, rust-colored expanses of the Australian outback. Its wings are vestigial, tiny, almost comical appendages hidden within its coarse, hair-like plumage, a relic of a flighted ancestry long since abandoned. Instead, its power lies in its legs, long and immensely powerful limbs that can carry it across the plains at speeds of 50 kilometers per hour, or around 31 miles per hour. Emus are nomads, their lives dictated by the capricious Australian climate, wandering vast distances in search of the rain and the flush of green growth that follows it. Their deep, drumming calls, produced by a unique inflatable sac in the trachea, are a low, resonant sound that carries for great distances, a haunting note in the symphony of the bush. The paternal care of the emu is a remarkable reversal of typical roles. It is the male who incubates the clutch of large, dark green eggs for 56 days, a period during which he does not eat, drink, or defecate, losing up to 1/3 of his body weight in a stunning act of paternal devotion. He then guards the striped, fast-running chicks for up to 7 months, fiercely defending them from dingoes, eagles, and other predators. If the emu is the familiar giant of the open country, its cousin, the southern cassowary, is the fearsome, reclusive spirit of the tropical rainforests of the continent's northeast. This is a bird that truly looks prehistoric. Standing slightly shorter than an emu, but often heavier, its body is draped in glossy black feathers. Its head and neck, however, are a shocking explosion of color. A bare canvas of vivid, iridescent blue and purple skin, with two long, red wattles hanging from its throat. Capping its head is a large, bony casque, a helmet-like structure whose exact function is still debated, but is thought to play a role in both display and as a tool for pushing through the dense rainforest undergrowth. The cassowary is a solitary and elusive creature, a critical frugivore that plays a vital role in the health of the rainforest by consuming and dispersing the seeds of over 100 different plant species, many of which are too large for any other animal to swallow. But for all its beauty, the cassowary has a well-earned reputation as one of the world's most dangerous birds. Its true weapon is not its beak or its casque, but the innermost of its 3 toes. This toe is armed with a single, formidable claw, a slender spike of bone and keratin that can grow to 12 centimeters, or nearly 5 inches, in length. When threatened, the cassowary leaps into the air and strikes downwards with a powerful kicking motion, using this claw as a dagger. It is capable of disemboweling a dingo, a domestic dog, or even a human with a single, well-aimed slash. This fearsome defense has allowed it to survive as a large, ground-dwelling bird in a formidable forest environment, a living dinosaur that commands respect. From the silent, intimidating presence of the cassowary, the Australian soundscape erupts with the voice of another iconic bird, the laughing kookaburra. Its call is one of the most recognizable sounds in the natural world, a boisterous, cascading chorus of what sounds for all the world like raucous human laughter. This sound is not an expression of mirth, but a complex territorial declaration, performed most often at dawn and dusk by a stable family group to advertise their ownership of a particular patch of woodland. The kookaburra is the world's largest member of the kingfisher family, but it has divorced itself from a dependence on water. It is a terrestrial predator, a sit-and-wait hunter that perches motionless on a branch, its keen eyes scanning the ground below for any sign of movement. Its prey is varied, including large insects, lizards, and even other birds. But it is most famous as a formidable snake hunter. Upon spotting its quarry, it dives from its perch, seizes the snake behind the head with its powerful, dagger-like bill, and then flies back to a favorite branch. Here, it proceeds to beat the reptile mercilessly against the wood, a violent and efficient method of killing its victim and tenderizing its flesh before swallowing it whole. This mastery of sound is taken to an entirely different, almost magical level by another of Australia's avian inhabitants, the superb lyrebird. Found in the wet eucalyptus forests of the southeast, the male lyrebird is a vocal prodigy without peer in the animal kingdom. It is nature's greatest mimic. While it has its own complex song, its true genius lies in its ability to perfectly replicate the sounds of its environment and weave them into an elaborate courtship symphony. A single male lyrebird can flawlessly imitate the songs of up to 20 other bird species that share its territory. But its talent does not stop there. It listens to the world around it with an artist's ear and incorporates other sounds into its repertoire. The whirring of a chainsaw, the click and wind of a camera shutter, the bark of a dog, a car alarm. The mimicry is so perfect as to be indistinguishable from the original. This incredible vocal display is performed on a specially constructed stage, a small mound of cleared earth on the forest floor. Here, the male performs his recital, and as he does so, he raises and fans his magnificent tail feathers over his head. These feathers, two long, lyre-shaped outer plumes, and a shimmering veil of finer, filamentary feathers, create a spectacular visual display that accompanies his vocal artistry. It is one of the most complex and beautiful courtship rituals on Earth, a testament to the powerful evolutionary force of sexual selection. This theme of avian intelligence is perhaps best exemplified by Australia's most conspicuous and numerous bird family, the parrots and cockatoos. The continent is the global center of their evolution, a place where they have diversified into a dazzling array of forms, from the vast, screeching flocks of budgerigars that turn the outback sky green, to the majestic, jet-black, red-tailed cockatoos. Among the most intelligent are the sulfur-crested cockatoos, large white birds with a brilliant yellow crest that they can raise and lower to express a range of emotions. Their cognitive abilities are remarkable, rivaling those of primates in some problem-solving tests. They possess long memories, form complex social bonds, and have demonstrated the ability to learn behaviors from one another, a clear sign of animal culture. In recent years, urban populations of these cockatoos have famously learned how to open the hinged lids of residential wheelie bins to scavenge for food, a complex, multi-step process that has been observed spreading from one flock to another as birds learn by watching their peers. Their beaks are immensely powerful tools, evolved to crack open the iron-hard nuts of native trees, like the quandong, but now just as adept at dismantling wooden window frames and outdoor furniture with apparent glee. This blend of high intelligence, social complexity, and destructive curiosity has allowed them to thrive in the rapidly changing, human-dominated landscapes of modern Australia. Yet for every loud, conspicuous cockatoo, there is a quieter, more subtle story of avian complexity unfolding in the undergrowth. This is the world of the superb fairy wren, a tiny bird whose social life is a saga of cooperation, deception, and infidelity that would rival any human drama. At first glance, they appear to live in simple, cooperative family groups. A dominant breeding pair is assisted in the arduous task of raising their chicks by a cohort of helper birds, usually males from previous broods who have not yet secured their own territory. These helpers work tirelessly, bringing food to the nest and defending the family's territory from intruders. It was long thought to be a straightforward example of kin selection, where the helpers ensure the survival of their own relatives. The advent of genetic testing, however, shattered this idyllic picture. Studies revealed that over 75% of nests contained young that were not sired by the dominant male of the group. The females, it turned out, were masters of infidelity. Under the cover of the pre-dawn darkness, they would make clandestine journeys into neighboring territories to solicit copulations from other males, often those with the most vibrant blue breeding plumage. The seemingly cooperative family unit was, in fact, a maelstrom of complex sexual politics, a sophisticated social web built on a delicate balance of public cooperation and private choice. From the thunderous strides of the cassowary to the intricate deceptions of the fairy wren, the birds of Australia demonstrate the incredible diversity of solutions that evolution can devise when given a continent of its own on which to work its endless and beautiful craft. But that same beautiful craft, when viewed through the lens of a much deeper, colder time, reveals a different kind of artistry. One not of song and feather, but of scale and silence. Long before the first kookaburra laughed or the first lyrebird sang, Australia was a kingdom of reptiles. They are the continent's true ancients, an unbroken dynasty stretching back into the Mesozoic haze, their forms and fortunes shaped not just by Australia's isolation, but by its core identity as a sun-scorched, often unforgiving land. They are the ultimate survivors, their cold-blooded metabolism, a perfect and patient adaptation to a world where energy is a currency to be conserved at all costs. At the very pinnacle of this reptilian ascendancy lies a creature that is itself a living fossil, an apex predator whose design was perfected over 100 million years ago and has required little modification since. This is the saltwater crocodile, Crocodilus porosus, the largest and most formidable reptile on Earth. In the sluggish, mangrove-choked estuaries and tidal rivers of northern Australia, it reigns supreme. A large male can grow to 7 meters, or nearly 23 feet in length, and weigh over 1,000 kilograms, more than 2,200 pounds. It is a creature of immense and terrible power, its body clad in a thick, armored hide of bony scutes, its movements in the water a study in silent, effortless grace. It can lie motionless for hours, a floating log with malevolent eyes, its nostrils and ears the only parts breaking the surface, patiently waiting for a wallaby, a wild pig, or any other creature to approach the water's edge. The attack, when it comes, is an explosion of primal violence. Propelled by its massive, muscular tail, the crocodile erupts from the water with a speed that defies its bulk, its jaws gaping wide. Those jaws are the most powerful in the living world, capable of slamming shut with a force of over 3,700 pounds per square inch, a bite that can crush the skull of a bull. Once it has its victim, the crocodile employs its signature killing technique, the death roll. Gripping its prey, it begins to spin its entire body with ferocious torque, a maneuver that both drowns the victim and tears its body apart into manageable pieces. This creature is a ghost from the age of dinosaurs, a survivor of the great extinction event that wiped them out 66 million years ago. Its physiology is a blend of the ancient and the highly advanced. Like a bird, it possesses a 4-chambered heart, allowing for a highly efficient separation of oxygenated and deoxygenated blood, a feature that enables it to stay submerged for over an hour, waiting in ambush. It has a remarkable tolerance for salt water, thanks to specialized glands on its tongue that excrete excess salt, allowing it to travel long distances in the open ocean, colonizing coastlines and river systems with ease. The saltwater crocodile is not merely an animal. It is a geological force, a living monument to a time when reptiles ruled the world, and in the wild north of Australia, they still do. From this reign of brute, physical force, we move to a different kind of reptilian dominance, one based not on size and jaw power, but on a mastery of biochemistry so profound it borders on the supernatural. Australia is infamous for its snakes, and for good reason. It is the only continent where venomous snake species outnumber the non-venomous, the result of a long and intense evolutionary arms race. At the apex of this venomous evolution is a creature of quiet and lethal potency, the inland taipan. This snake, found in the remote, cracking clay floodplains of the arid interior, is, by a significant margin, the most venomous land snake in the world. Its venom is a highly complex neurotoxic cocktail designed to shut down the nervous system of its warm-blooded prey, primarily the long-haired rat, with shocking speed. The sheer toxicity is difficult to comprehend. The yield from a single bite, a mere 40 to 100 milligrams, is enough to kill over 100 adult men or 250,000 mice. Yet, for all its lethal potential, the inland taipan is a reclusive, almost timid creature. It shuns confrontation, and human encounters are exceedingly rare, a paradox that highlights a crucial distinction. The most venomous animal is not necessarily the most dangerous. That title belongs to a different snake, one whose temperament and proximity to humans make it a far greater threat. This is the eastern brown snake, a slender, fast-moving, and notoriously nervous species that thrives in the agricultural and even suburban landscapes of the populous East Coast. Its venom, while still incredibly potent, ranks second to the taipan's, but its defensive disposition is what makes it so perilous. When surprised or cornered, it will not hesitate to strike, often delivering multiple bites in quick succession. Its presence in the very places where most Australians live and work results in far more encounters and, tragically, more human fatalities than any other snake on the continent. Beyond these masters of death, the reptilian story diversifies into a gallery of strange and wonderful specialists, lizards that have adopted bizarre and beautiful solutions to the challenges of Australian life. In the woodlands of the north, an encounter with a frilled neck lizard is a moment of pure natural theater. For most of its life, it is an unassuming gray-brown lizard, well camouflaged against the tree bark where it spends its time. When threatened, however, it undergoes a startling transformation. It whips open its mouth, which is lined with a startling yellow or pink interior, and in the same instant, erects a huge, circular ruff of skin from around its neck. This frill, which can be up to 30 centimeters or nearly 12 inches across, is supported by long spines of cartilage and is brightly colored in shades of orange and red. The sudden, shocking display makes the lizard appear far larger and more intimidating than it actually is. If this terrifying bluff fails to deter a predator, the lizard turns and flees, not on four legs, but by rising up onto its powerful hind limbs and sprinting away in a comical, bipedal run. It is a spectacular performance, a masterpiece of intimidation and misdirection. But for the ultimate expression of reptilian adaptation to the harshest of Australian environments, we must travel to the red sand deserts of the deep interior, the home of the thorny devil. This small lizard is a living fortress, its entire body, from its head to its tail, covered in a formidable array of conical, non-calcified spines. It moves with a slow, rocking, and deliberate gait, a tiny, ant-eating monster from a fantasy world. Its most prominent defense is a large, spiny mum on the back of its neck, a false head that it presents to predators when it dips its real head down, a clever decoy designed to absorb an attack. Yet its most incredible feature is not for defense, but for survival in a world almost devoid of water. Its skin is a marvel of biological engineering. Between its overlapping scales runs a complex, interconnected network of microscopic grooves. This network functions as a system of capillary tubes. When the morning desert mist settles or a rare rain shower falls, the thorny devil can collect the moisture on any part of its body. The capillary action of the grooves then draws this water against gravity across the surface of the skin, channeling it directly to the corners of the lizard's mouth, allowing it to drink without ever needing to find a puddle. It is a creature that wears its own drinking fountain. From the terrifying, bone-crushing power of the saltwater crocodile to the subtle, moisture-harvesting skin of the thorny devil, Australia's reptiles showcase a different kind of evolutionary genius. A patient, ancient, and deeply successful strategy for life, etched in scale and bone and written in the very dust of the continent itself. This ancient genius, etched in the very dust of the continent, found its limit at the water's edge. For here, where the sun-scorched land gives way to the sea, an entirely different and far more vibrant story of life was unfolding. Along the northeastern coastline of this arid continent lies its liquid antithesis, a sprawling, iridescent kingdom of such immense scale and biological richness that it stands as the single largest structure ever built by living organisms on our planet. This is the Great Barrier Reef, a living rampart stretching for over 2,300 kilometers, or more than 1,400 miles. A filigree of coral cays, islands, and submerged reefs so vast that it is clearly visible from the moon. It is not a single, continuous wall, but a complex mosaic of nearly 3,000 individual reefs and 900 islands, a metropolis of life that dwarfs any city ever built by humankind. The architects of this colossal wonder are tiny, humble creatures, the coral polyps. Each polyp is a simple, soft-bodied animal, a close relative of a jellyfish that lives within a protective limestone cup of its own making. But it does not live alone. Embedded within its tissues are millions of microscopic, single-celled algae called zooxanthellae. This is one of nature's most profound and successful partnerships. The coral polyp provides the algae with a safe, sunlit home and the raw materials for photosynthesis, while the algae, in return, harness the power of the sun to produce sugars and other organic compounds, providing the polyp with up to 90% of its energy needs. It is this symbiotic engine that powers the reef. Using the energy from their algal tenants, the polyps extract calcium carbonate from the seawater and secrete it, molecule by molecule, to build their limestone skeletons. Generation after generation, for millions of years, these tiny builders have lived and died, their skeletons forming the foundations upon which their descendants build. A slow, patient act of biological construction that has created a three-dimensional labyrinth of breathtaking complexity. This structure provides the stage for an explosion of biodiversity that almost defies belief. The reef is a living kaleidoscope, home to over 1,500 species of fish, more than 400 types of hard coral, 6 of the world's 7 species of sea turtle, and 30 species of whales and dolphins. In this teeming, hyper-competitive world, every inhabitant has carved out a specialized niche. Consider the relationship between the clownfish and the sea anemone. The anemone's tentacles are a forest of lethal, stinging cells a death trap for any other small fish that blunders into them. The clownfish, however, is immune. It covers its body in a layer of protective mucus, which it may acquire by gently acclimating itself to the anemone's stings, effectively cloaking itself from the host's weaponry. This immunity allows it to live safely within the anemone's deadly embrace, protected from predators, while its own movements may help to clean the anemone and lure in other prey. Elsewhere on the reef, another fish is not seeking refuge, but is actively shaping the very environment itself. This is the parrotfish, a brightly colored creature with a formidable mouth. Its teeth are fused into a powerful, beak-like structure, strong enough to bite off chunks of the coral itself. It is not eating the coral polyp, but rather scraping away at the rock to get to the algae growing on its surface. As it digests the algae, its powerful pharyngeal teeth grind the ingested coral skeleton into a fine powder, which is then excreted as sand. A single large parrotfish can produce up to 900 kilograms, or nearly 2,000 pounds, of fine, white sand every year, playing a crucial and irreplaceable role in controlling algae and creating the idyllic, sandy beaches of the reef's islands. The scale of life here extends from the tiny to the truly immense. Giant groupers, weighing up to 400 kilograms, or close to 900 pounds, lurk in caves and under ledges, their cavernous mouths capable of swallowing smaller sharks whole. 6 species of sea turtle, including the majestic green sea turtle, navigate these coral gardens, making epic migrations across the ocean to feed and to return to the very beaches where they were born. Each year, on islands like Rain Island at the reef's northern tip, tens of thousands of female green turtles haul themselves ashore in a single, synchronized nesting event, a primeval ritual that has played out for millennia. This warm, protected lagoon is also the destination for one of the planet's greatest migrations. Every winter, thousands of humpback whales travel north from the frigid feeding grounds of Antarctica to the sheltered waters of the reef. Here, they give birth to their calves and nurture them through the first few months of their lives, their complex, haunting songs echoing through the coral canyons, a temporary acoustic layer to this vibrant visual world. But this teeming, beautiful metropolis is a paradox. Its immense size belies a profound fragility. It exists in a delicate balance and is now facing threats on an unprecedented scale. Outbreaks of the native crown of thorns starfish, a voracious coral predator, can sweep through a reef system, leaving a trail of white, dead skeletons in their wake. But the most insidious and existential threat is born of a warming planet. The symbiotic relationship between the coral and its algae is temperature sensitive. When the ocean temperature rises by just 1 or 2 degrees Celsius, or a couple of degrees Fahrenheit, for a prolonged period, the stressed coral polyps expel their colorful algal partners. This is coral bleaching. The coral is not yet dead, but it has lost its primary food source and its color, revealing the stark white limestone skeleton beneath. If the water temperature returns to normal quickly, the corals can recover. But if the heat stress persists, they will starve and die, leaving behind a barren, algae-choked graveyard. While this epic drama of life and death unfolds in the clear, sunlit waters of the Pacific, a different, quieter, and far more ancient aquatic story persists in the continent's murky, freshwater rivers. These waterways are often ephemeral, swelling with floodwaters in the wet season and shrinking to a series of disconnected pools in the dry. Life here requires not diversity, but endurance. And no creature embodies this principle of ancient resilience more than the Australian lungfish. This is a true living fossil, a silent, armored ghost from a time long past. Its lineage stretches back unbroken for nearly 400 million years, a survivor from the Devonian period, the age of fishes. It lived in the rivers of Gondwana long before the dinosaurs evolved and has outlasted them by 66 million years. The lungfish is a large, sluggish creature, growing to over 1.5 meters, or about 5 feet long, with a heavy, bony scaled body and fleshy, limb-like pectoral fins. Its secret to survival, the trait that has allowed it to persist through countless climatic shifts that drove other species to extinction, is its ability to breathe air. While it possesses fully functional gills, it also has a single, primitive lung, a direct connection to the lungs of all terrestrial vertebrates, including our own. When its river home becomes stagnant and low in oxygen during the dry season, the lungfish can rise to the surface and gulp air, allowing it to survive in conditions that would be fatal to most other fish. It is not an adaptation to Australia's modern climate. It is an ancient trait from a far older world, a piece of biological equipment that just happened to be the perfect tool for surviving the continent's long, slow drift into aridity. The Australian lungfish is a poignant reminder that survival is not always about innovation, but sometimes about simply holding on, a living bridge to an almost unimaginably distant past. Both this ancient, tenacious survivor and the vast, vibrant, and vulnerable reef system, however, were on a collision course with a new and unpredictable force, a presence that would alter the continent's waterways and indeed every aspect of its fauna in ways that millions of years of natural evolution could never have anticipated. That new and unpredictable force arrived on the shores of Australia in a wave of human migration that would ultimately rewrite the continent's ecological destiny, not once, but twice. The first arrival, a story of epic seafaring and remarkable adaptation, began at least 65,000 years ago. During a period of the last ice age, when global sea levels were as much as 150 meters, or nearly 500 feet lower than they are today. The geography of the region was dramatically different. The islands of Indonesia and New Guinea were joined into a single great landmass called Sunda, while Australia and New Guinea were connected, forming the continent of Sahul. Yet even at the lowest point of sea level, a significant oceanic trench, the Wallace Line, a deep water channel that had existed for millions of years, still separated the two landmasses. Crossing this treacherous strait, a journey that would have required a sea voyage of at least 90 kilometers, or 56 miles, represents one of the earliest and most definitive proofs of purposeful seafaring by early modern humans. These were not accidental drift voyages. They were planned, navigated journeys into an unknown world, a testament to the cognitive and technological sophistication of these first explorers. The people who arrived on the northern shores of Sahul were stepping into a world that no human had ever seen, a land dominated by the giant beasts of the megafauna. For at least 20,000 years, humans and these colossal creatures coexisted. The first peoples were supremely skilled and knowledgeable hunter-gatherers, their culture and technology perfectly attuned to the rhythms of the Australian environment. They developed a vast and intimate understanding of the land, a knowledge system built on thousands of generations of observation and passed down through complex oral traditions and artistic practices. They learned the properties of every plant, the habits of every animal, and the locations of every water source in even the most arid of landscapes. Their impact on the fauna was profound. As we have seen, the pressure from their hunting, and more significantly, their systematic use of fire to manage the landscape, fire stick farming, likely contributed to the extinction of the megafauna. This was not an act of wanton destruction, but a process of environmental engineering that created a landscape more suited to their own needs, promoting the growth of open grasslands and the animals they preyed upon, like kangaroos and wallabies, which thrived in this new, more open environment. Their relationship with the native fauna was not simply one of predator and prey. It was far deeper, a spiritual and cultural symbiosis. The animals were not just resources. They were kin, ancestors, and creators, woven into the very fabric of their cosmology, the dreaming. This complex worldview holds that the entire landscape, every rock, river, and waterhole, was shaped by the journeys and actions of powerful ancestral beings during a creative era. These beings often took the form of animals, such as the rainbow serpent, a creator deity associated with water and the life it brings, or the kangaroo and emu, whose ancestral journeys are mapped across the continent in song lines and sacred sites. This profound connection meant that the fauna was treated with a deep and abiding respect, its existence integral to the spiritual health of the people and the land. They developed sophisticated systems of customary law that governed the hunting of certain species, ensuring their populations remained sustainable. This was a relationship of custodial responsibility, a long and stable coexistence that, following the initial upheaval of the megafauna extinction, settled into a dynamic equilibrium that lasted for tens of thousands of years. This ancient, stable world was shattered by the second arrival, an event that began on the 29th of April, 1770, when the HMS Endeavour, a ship under the command of Lieutenant James Cook, dropped anchor in a wide, sheltered bay on the southeastern coast of the continent. Cook and the naturalist Joseph Banks, who stepped ashore into this land they would name Botany Bay, were the harbingers of a biological and cultural invasion that would prove to be catastrophic for Australia's native fauna and its first peoples. The British settlement that followed in 1788 was not merely a human colonization. It was a vast, unplanned, and utterly devastating ecological experiment. The newcomers did not see a landscape shaped and managed by a sophisticated human culture. They saw a wild, untamed wilderness, a terra nullius, or empty land, to be conquered and remade in the image of their European homeland. They brought with them a complete suite of European animals, an ark of their own that was utterly alien to the Australian ecosystem. The sheep and cattle that formed the backbone of the new pastoral industry began to compact the fragile soil with their hard hooves and graze the native grasses down to the roots, outcompeting the soft-footed kangaroos and wallabies. The settlers cleared vast tracts of forest and woodland to create pasture and farmland. A process of habitat destruction on a scale that dwarfed the fire stick farming of the indigenous population. But the most devastating impacts came not from the livestock, but from the smaller, more insidious stowaways and deliberate introductions. The black rat, arriving on the very first ships, quickly spread, wreaking havoc on native bird and small mammal populations that had no defense against such a rapacious and efficient predator. But the true agents of destruction were introduced with a sense of misplaced nostalgia, an attempt by the colonists to make the alien Australian landscape feel more like home. The European rabbit was introduced in 1859 by a Victorian grazier named Thomas Austin, who imported 24 wild rabbits for sport. His seemingly innocuous act unleashed a biological plague. The Australian environment, with its mild winters and vast open spaces, was a paradise for rabbits. With no significant natural predators to control them, their population exploded at a rate that was almost biblical. Within 50 years, they had spread across the entire southern half of the continent, the fastest spread of any mammal species anywhere in the world. They devastated the landscape, eating native vegetation down to the bare earth, leading to massive soil erosion and the extinction of numerous native plant species. They outcompeted native herbivores like the bilby and the burrowing betong, taking over their burrows and stripping their food sources. The rabbit plague was a slow-motion, continent-wide catastrophe. In an attempt to control the rabbits, the colonists committed another monumental ecological blunder. They introduced the European red fox in the 1870s, believing the skilled hunter would prey on the rabbit population. The fox did indeed prey on rabbits, but it found Australia's native mammals to be a far easier and more rewarding target. The small to medium-sized, ground-dwelling marsupials, creatures in the so-called critical weight range between 35 grams and 5.5 kilograms, had evolved in a world free of such an efficient, stealthy predator. They were naive, unwary, and utterly defenseless against the fox's cunning. The result was a bloodbath. Dozens of species, from the desert rat kangaroo to the crescent nail-tail wallaby, were driven to extinction in a wave of carnage that swept across the continent in the wake of the fox's advance. The domestic cat, which had also arrived with the first settlers and quickly established feral populations, joined the fox in this devastating assault, its skill as a hunter proving just as lethal to native birds, reptiles, and small mammals. This 1-2 punch of the fox and the cat represents the single greatest threat to Australia's surviving native fauna today. This second invasion, this European remaking of the continent, severed the ancient 65,000-year-old relationship between people and the land. It replaced a system of custodial respect with one of commercial exploitation, and in doing so, unleashed a Pandora's box of invasive species that tipped the continent's finely balanced ecosystem into a state of permanent, cascading crisis. The consequences of this collision of worlds are still being felt, a legacy of extinction and loss that has left deep and permanent scars on the ancient fauna of this isolated land. The deep and permanent scars left by this collision of worlds are not relics of a distant past. They are living wounds, actively festering and spreading across the continent in a relentless biological siege. The Pandora's box of invasive species, once opened, could not be closed, and its contents proved to be even more monstrous and varied than the initial plagues of rabbits and foxes. Perhaps no story better illustrates the catastrophic blend of good intentions and ecological ignorance than the saga of the cane toad. The year was 1935, and the sugarcane industry in the tropical state of Queensland was facing a serious threat from two native insects, the greyback cane beetle and the Frenchy beetle. In their larval stage, these beetles would feast on the roots of the sugarcane, causing immense economic damage. Looking for a solution, the agricultural scientists of the day turned their eyes overseas to a successful case of biological control in Puerto Rico, where the large, carnivorous cane toad, Rhinella marina, a native of South and Central America, had apparently been used to control similar pests. The idea seemed simple and elegant. Introduce a natural predator to solve a natural problem. Despite warnings from some skeptical scientists, the plan was pushed through with bureaucratic and industrial zeal. 102 toads were imported from Hawaii, bred to increase their numbers, and then released into the cane fields of northern Queensland. The failure was immediate, total, and spectacular. The proponents of the scheme had overlooked a few simple yet critical details of the local ecology. The cane beetles they were targeting lived high up on the stalks of the sugarcane and were most active during the dry season. The cane toads, on the other hand, are ground-dwelling amphibians that cannot climb, and they require moisture to breed, making them most active during the wet season. The predator and the prey barely ever crossed paths. The toads, finding themselves in a new world with no familiar constraints and an abundance of other food sources, did what they do best. They ate and they bred. The invasion began. A female cane toad can lay up to 30,000 eggs at a time, twice a year, in long, gelatinous strings. The resulting tadpoles are highly toxic, killing the native fish and other aquatic life that attempt to eat them. From their initial release point, the toads began to spread, an inexorable warty tide marching across the landscape. Their advance, currently at a rate of up to 60 kilometers, or nearly 37 miles per year, has now carried them across Queensland, into the Northern Territory, and down into New South Wales. Their devastating success is built on a single, powerful weapon: poison. The cane toad is a chemical warfare factory on legs. Large parotid glands on its shoulders secrete a milky white venom known as bufotoxin, a potent cocktail of cardiac glycosides that can cause hallucinations, cardiac arrest, and death in animals that ingest it. Australia's native predators, the quolls, the goannas, the snakes, the crocodiles, had evolved over millions of years with a native frog fauna that was entirely non-toxic. They had no evolutionary experience with such a deadly amphibian. For them, a toad was simply a slow, easy meal. This ecological naivety proved fatal. When the toad invasion front arrives in a new area, the local predator populations collapse. Large goannas, northern quolls, and even freshwater crocodiles, upon encountering their first cane toad, bite down and receive a lethal dose of venom, dying within minutes. The landscape falls eerily silent. The top-tier native predators wiped out, leaving a vacuum that the toad and other pests are quick to fill. The cane toad is a walking ecological disaster, a monument to the law of unintended consequences, a plague born of human hubris that continues to spread with no end in sight. The invasion was not confined to the land. Beneath the surface of Australia's greatest river system, the Murray-Darling Basin, Another ecological catastrophe was quietly unfolding. This time, the culprit was a fish, the common carp, deliberately introduced on multiple occasions throughout the 19th and 20th centuries as a sporting and food fish. The particularly aggressive Boulara strain was released into the basin in the 1960s and quickly established a dominant presence. Carp are the rabbits of the river. They are incredibly hardy, tolerating a wide range of temperatures and water conditions, and they are prolific breeders. But their most destructive trait is their feeding method. They are bottom feeders, cruising through the riverbed and sucking up mud and vegetation, filtering out invertebrates and plant matter before spitting out the sediment. This process, known as bioturbation, has a catastrophic effect on the river ecosystem. It constantly stirs up the mud, dramatically increasing the water's turbidity. The perpetually cloudy water blocks sunlight from reaching the riverbed, killing off the native aquatic plants that once stabilized the banks and provided crucial habitat and food for a vast array of native species. The carp's relentless feeding destroys the nests and smothers the eggs of native fish like the Murray cod and the golden perch, while directly outcompeting them for the dwindling food resources. In many stretches of the Murray-Darling today, carp make up over 80% of the total fish biomass, a staggering dominance that has turned once clear, vibrant rivers into murky, degraded monocultures. The assault on the Australian environment has also been waged by invaders from the plant kingdom, a silent, creeping conquest that can be just as devastating as any animal plague. The story of the prickly pear cactus in the early 20th century is a classic example. Introduced as a garden ornamental and for its fruit, several species of Opuntia cactus escaped cultivation and went on to infest over 25 million hectares, or more than 60 million acres, of grazing land in Queensland and New South Wales by 1925, an area larger than the entire United Kingdom. The land was rendered completely useless, covered in dense, impenetrable thickets of spiny cactus. The crisis was only solved by another introduction, one of the few truly successful examples of biological control in history. The Cactoblastis cactarum moth, whose larvae burrowed into the cactus pads and devoured them from the inside out, bringing the plague under control in a little over a decade. But other botanical invaders have proven far less tractable. In the precious wetlands of Australia's top end, such as the World Heritage-listed Kakadu National Park, the thorny shrub Mimosa pigra has become a modern nightmare. This fast-growing, woody weed forms dense, monotypic thickets up to 6 meters, or nearly 20 feet high, that completely choke out the native sedges and grasses. These thickets are so dense they are impenetrable to sunlight and to most animals, destroying the open floodplain habitats that are essential feeding grounds for millions of water birds, such as the iconic magpie goose. The very hydrology of the landscape is altered. The delicate balance of the wet-dry tropics thrown into chaos by a single belligerent shrub from Central America. The cumulative effect of these invasions, from the toad to the carp to the mimosa, has been to place the continent's native fauna under a state of permanent siege. The financial cost of fighting this war is astronomical, with billions of dollars spent annually on research, control programs, and the construction of vast exclusion fences in a desperate attempt to protect what is left. But the true cost is ecological. These invaders do not just occupy space. They actively dismantle the intricate web of relationships that define an ecosystem. They poison predators, outcompete native species, and fundamentally re-engineer the landscape, creating a cascade of extinction and loss that flows through the entire system. The battle against invasive species is now a central and defining feature of modern Australian conservation. A relentless, often heartbreaking struggle against a tide of biological pollution. It requires a new form of human intervention, a conscious and scientifically guided effort to mend the very ecosystems that a previous generation's carelessness so thoroughly broke. In the face of this relentless, multi-fronted assault, a new kind of human presence has begun to assert itself across the Australian continent. It is a presence born not of exploitation or nostalgic terraforming, but of a desperate and determined sense of custodial responsibility. This is the world of modern conservation, a diverse and often beleaguered army of scientists, volunteers, indigenous rangers, and policymakers united by a single, urgent mission: to hold the line, to protect the irreplaceable remnants of Australia's unique natural heritage from slipping into oblivion. Their battlegrounds are the fragmented patches of old-growth forest, the remote, predator-free islands, the sterile laboratories of captive breeding programs, and the fiercely debated corridors of political power. Their work is a complex blend of cutting-edge science, grueling fieldwork, and a profound, often heartbreaking, emotional commitment to the species they are fighting to save. One of the most ambitious and innovative fronts in this war is the creation of mainland islands, a concept that attempts to replicate the security of an offshore island in a continental setting. This involves constructing massive, predator-proof fences to enclose large areas of suitable habitat, creating vast, open-air sanctuaries from which feral cats, foxes, and rabbits can be completely eradicated. A prime example of this strategy is arid recovery, a conservation project in the stony desert of northern South Australia. Here, a fence stretching for over 123 square kilometers, or nearly 48 square miles, encloses a landscape that has been systematically cleared of every last feral predator. The fence itself is a marvel of defensive engineering, with a floppy, overhanging top to prevent cats and foxes from climbing over, a fine mesh skirt buried deep underground to stop rabbits and predators from digging under, and electrified wires to provide an extra deterrent. Within this fortified perimeter, an echo of a lost world is being painstakingly reassembled. Species that had been locally extinct for over a century, small marsupials like the greater bilby, the burrowing betong, and the western quoll, have been reintroduced. These creatures, once on the brink of total extinction, are now thriving in this predator-free haven, breeding and behaving as they would have done before the European invasion. These fenced sanctuaries are not a perfect solution. They are enormously expensive to build and maintain, and they represent a form of ecological life support. But they serve as critical genetic arcs, keeping populations of the most vulnerable species alive, while broader, more landscape-scale solutions to the feral predator problem are sought. While some conservationists build fences, others take to the lab, harnessing the power of genetics and reproductive biology to pull species back from the very edge of the void. The plight of the Tasmanian devil, the world's largest surviving carnivorous marsupial, provides a stark and urgent case study. In the mid-1990s, a horrifying and unprecedented disease began to sweep through the devil population of Tasmania. Known as devil facial tumor disease, or DFTD, it is one of only a handful of known transmissible cancers. The cancer is spread by biting, a common behavior in the species' aggressive social interactions, and it causes grotesque tumors to grow on the animal's face and neck, eventually preventing it from feeding and leading to death by starvation. The disease proved to be almost 100% fatal and spread with terrifying speed, wiping out over 80% of the wild devil population in just 2 decades and pushing the species to the brink of extinction. In response, a massive conservation effort was launched, centered on the creation of a disease-free insurance population. Healthy, uninfected devils were captured from the wild and placed in a highly coordinated captive breeding program across dozens of zoos and wildlife parks in Australia. Using sophisticated genetic analysis to manage breeding pairs and maintain maximum genetic diversity, the program has successfully built a robust, healthy, and genetically diverse population of hundreds of devils, safe from the ravages of the disease. Now, in a hopeful new phase of the project, devils from this insurance population are being released back into the wild in parts of Tasmania where the disease has faded, and even onto predator-free islands and a large fenced sanctuary on the Australian mainland, a bold experiment in rewilding. This hands-on, intensive management is not limited to mammals. In the cool, montane streams of the Victorian Alps, a desperate battle is being waged to save one of Australia's most unusual and critically endangered amphibians, the southern corroboree frog. This tiny, striking creature, with its vivid yellow and black stripes, has been all but wiped out in the wild by a deadly, introduced pathogen, the amphibian chytrid fungus, a skin disease that has caused frog extinctions and declines all over the world. The frog's wild population has collapsed to a mere handful of individuals. The only thing standing between the corroboree frog and total extinction is a dedicated captive breeding program. At facilities like the Taronga Zoo in Sydney, conservationists have had to become masters of recreating the frog's entire life cycle in a controlled environment. They have had to replicate the precise temperature and humidity conditions of the frog's alpine habitat, from creating artificial, chilled breeding chambers to simulate the winter cold, to providing the sphagnum moss nests in which the females lay their eggs. It is an incredibly delicate and labor-intensive process, raising thousands of the tiny, vulnerable tadpoles and froglets for eventual release back into specially protected, disease-free field enclosures in the mountains. This program is a stark illustration of the extreme lengths and meticulous scientific detail required to keep a species' flame alive in the modern world. Alongside these scientific interventions, a powerful and transformative movement is gaining momentum, one that reconnects the practice of conservation with the oldest traditions of Australian land management. This is the rise of Indigenous Protected Areas, or IPAs, and the Indigenous Ranger Program. These initiatives recognize that the First Peoples, with their 65,000 years of accumulated ecological knowledge, are uniquely placed to manage and restore their traditional lands. The IPA program empowers Indigenous communities to declare their lands as protected areas, which are then managed according to a combination of traditional ecological knowledge and contemporary conservation science. The Indigenous ranger groups who manage these lands are the modern embodiment of that ancient custodial ethic. They are on the front lines of conservation, controlling feral animals and invasive weeds, managing fire regimes using traditional burning practices that reduce the risk of catastrophic wildfires and promote biodiversity, and monitoring the health of threatened species. This movement is a profound and vital shift in the conservation paradigm, moving away from a purely scientific, top-down approach and towards a more holistic model that integrates culture, community, and science. It is a recognition that the deep spiritual connection to country is one of the most powerful tools in the fight to heal it. From the high-tech, fortified fences of arid recovery to the patient, ancestral knowledge of an Indigenous ranger monitoring a sacred waterhole, the guardians of Australia's Ark are fighting a difficult and often uncertain battle. Their work is a testament to a growing understanding that the continent's unique fauna is not merely a collection of strange and wonderful creatures, but a living, breathing inheritance, a story of deep time and magnificent isolation that, once lost, can never be retold. Our journey through the strange and singular world of Australian fauna has taken us from the deep, green twilight of Gondwana to the sun-scorched landscapes of the present day. We have seen how the continent's long, solitary voyage as a great evolutionary arc fostered a menagerie of life found nowhere else, a second genesis that ran in parallel to the rest of the world. We have walked with the colossal megafauna of the Pleistocene and explored the reasons for their mysterious demise, a story intertwined with the arrival of the first ancient wave of humanity. We have marveled at the brilliant opportunism of the marsupials, whose pouch-based strategy for reproduction proved to be the master key to a continent of climatic extremes, producing the bounding kangaroo, the chemically specialized koala, and the earth-moving wombat. We have delved deeper still into the world of the monotremes, uncovering the ancient contract of the egg-laying platypus and echidna, living relics from the very dawn of mammals. We have listened to the symphony of the birds, from the dinosaurian echoes of the emu and cassowary to the sublime mimicry of the lyrebird, and witnessed the silent, cold-blooded reign of the reptiles, a dynasty of ancient crocodiles and the world's most venomous snakes. From the vibrant, teeming metropolis of the Great Barrier Reef to the lone, air-breathing resilience of the lungfish, we have seen how life adapted to every conceivable niche. But we have also seen how this ancient and finely balanced world was shattered by the abrupt and shattering arrival of a second human wave, one that brought with it the hard-hoofed livestock, the rabbit, the fox, and the cane toad, unwittingly unleashing plagues that have tipped the ecosystem into a state of enduring crisis. The story of Australian fauna is therefore no longer a simple tale of evolution in isolation. It is now a dramatic and uncertain narrative of survival in the face of immense human-induced pressure. The guardians of this arc are now engaged in a desperate defensive battle, building fences to hold back the tide of extinction, working in laboratories where life's flame is coaxed back from the embers, and rekindling an ancient, custodial connection to the land. The Great Australian Arc, for so long a vessel of magnificent solitude, has become a fragile vessel in a turbulent sea of global change. Its unique cargo, the result of over 45 million years of an uninterrupted evolutionary experiment, now faces its greatest test. Its future and the fate of this irreplaceable chapter in the story of life on Earth now rests entirely in our hands.